What I would like you to do is to solve example A with your partner, just because A is one of the more basic types that I think you guys could navigate without any help, any guidance. So try example A, and then we'll come together and check our answers. So as I was walking around the classroom, I saw many people have the answer x equals 4, y equals 3, z equals 4. Just so you know, this is how I will ask you to list your answers as well as how your book lists the answer. Just in alphabetical order, they list as an ordered pair, or really an ordered, not an ordered pair, ordered triple, 4, 3, 4. Now this one was pretty easy to navigate just because the last equation only involved one variable. But a lot of what you did is actually going to be consistent with solving these types of equations. Let's take a look at example C. Or really, I didn't say C. Let's look at the example on the bottom page here. This one's not quite as easy to work with because we don't have only one variable. Does anybody have an idea of what we could do if we now have 3 variables? Ethan?
Well, since there always 1, 2, and 3,
so you're taking a look at the different variables as far as they have factors of 3 and 2? We will have to use those, that's true. Zach?
Just like at that point, just come up and solve it. Oh.
Right now, what system do we know how to solve with how many variables? 2. So what we can do here is if I mark these equations as 1, 2, and 3, I could eliminate a variable until I'm left with a system of 2 equations with 2 variables. So look at equations 1, 2, and 3. Which variable, if I'm just choosing 2 of the equations to work with, which variable looks easiest to eliminate? Oh, actually you could say y or z, right? If you choose equation 1 and 3, it's easy to eliminate z. Or if you choose equations 2 and 3, it would be easy to eliminate y. So let's just hear, Abby, which one do you want to choose, to eliminate y or z?
Y.
Y, okay. So we're going to choose equations 2 and 3, and this is how you'll see me mark up my work off to the side. Using equations 2 and 3, I'm going to eliminate y. So I have 2x minus y plus z is equal to 8. And I have 3x plus y minus 2z is equal to negative 1. And I add straight down. 8 minus 1 is 7. Z plus negative 2z is negative z. Y is eliminated, and 2x plus 3x is equal to 5x. Now, I will always, and I'll ask you at least for this example, to label that equation A, because we are going to need it. We are going to come back to it. Okay, just for future reference, let's label what we did in step 1. Step 1 was choose 2 equations to eliminate a variable. So back here in step 1, go ahead and write in, choose 2 equations to eliminate a variable. Okay, I called that equation A. Step 2 is you need to choose the equation you have not worked with yet. So which equation have we not worked with yet? Equation 1. I have to choose equation 1 and one of the others that I have to eliminate the same variable. Because I want a system of equations with just 2 variables. Those are ones I know how to easily solve. So step 2, let's take equation that we haven't worked with. So we're going to take equation 1, which is x plus 3y plus 2z equals 5. And we have to eliminate the same variable. So which variable do I have to eliminate, x, y, or z? Y, because that's the one that I eliminated up here. So which equation would you guys want to use, 2 or 3, to eliminate y? 2, okay. So equation 2 would be 2x minus y plus z. You can. It doesn't matter, to be honest. So you could keep going with equation 3 and it should still work out. But if being consistent in eliminating the same variable, what would I have to multiply the bottom equation by? 3, good. So I'll multiply this by 3 here and show my new equation off to the right. It would be 6x minus 3y plus 3z is equal to 24. And that first equation I'm going to use to eliminate x plus 3y plus 2z is equal to 5. Add straight down. X plus 6x is 7x. 3y minus 3y eliminates. And then I have 5z is equal to 29. What do you think I'm going to have you call this equation? B. Why was it so important that we had to eliminate y? Because now we have equation A and B with the same variables. Can we use A and B to solve for x and b? Yeah. But let's write down what we did in step 2. So step 2 is choose a different combination of equations to eliminate the same variable. So write that down. Choose a different combination of equations to eliminate. Now I'm going to write the word same in capital and different color just because it's really important that you do the same variable as step 1, otherwise you're going to get pretty lost. To eliminate the same variable. Okay, so now that we have equations A and we have equations B, we can solve using that system. So I'm going to go ahead and reset this up with A and B. A was 5x minus z is equal to 7. And B was 7x plus 5z is equal to 29. And which variable do you guys want to choose to eliminate, z or x? Z, so what would we have to multiply the top equation by? 5, good. And that would give us 25x minus 5z is equal to 35. And my other equation, which was 7x plus 5z equals 29, I can add to that. 25x plus 7x is 32x. Negative 5z and 5z eliminate. 35 and 29 come out to be 64. Divide by 32, and what do we get x to equal? 2. And then what do you think we would do with x? Plug it into A or B, right? To solve for variable z. So if I plug it into A, I would have 5 times 2 minus z is equal to 7. So 10 minus z equals 7. Subtract 10, so negative z is equal to negative 3. And z is equal to 3. Okay, that was step 3. We'll write that down. What do you think step 4 would be?
Plug those two back into one of the equations.
Exactly right. Plug these two back into an original equation to solve for the last variable. But just because we're going to want to be able to refer back to these notes as far as what steps we did, let's go ahead and write down step 3. Step 3 is to solve the system of two equations. That's your A and B. The system of two equations with two variables. And then we can even write step 4. Step 4 is to plug the variables into an original equation. So solve for last variable with an original equation. Okay, so let's go ahead and do that, and then I'll have you practice one on your own. So plugging into, I'll plug it into equation 1, which was x plus 3y plus 2z is equal to 5. So that would give me 2 plus 3y plus 2 times 3 is equal to 5. 2 plus 6 would give me 8. So if I subtract 8 from 5, that would give me 3y is equal to negative 3. And so y is equal to negative 1. And to write our answers, we would write in order of x, y, z, alphabetical order, 2, negative 1, and 3. Now, because you know you're going to have one of these on a test or a quiz, it's important to understand how could I check my answer. And here's my strong emphasis to you. Don't just choose one equation to check it into. If you are at a test or a quiz and you want to make sure you're right, check it into all three. And you'll find that it might be easier than you think. Just do it mentally. But I've often made a little mistake in my algebra, and I got lazy. I only checked it into 2 equations, and I didn't see that I made a mistake because I didn't check it into the third. So even if we just visually check, when x is 2, I would have 2 minus 3 plus 6. 2 minus 3 is negative 1 plus 6 does equal 5. 4 plus 1 plus 3 would give me 8. And 6 minus 1, which is 5, minus 6, does equal negative 1. So right there, I just kind of did a quick check in my head, and I know that it works out. Okay, you all have a partner. What I'm going to ask you to do is to do example 3 together. Here's why I'm asking you to do it together. It's so easy to drop negatives or multiply incorrectly or add incorrectly when working with these types of steps. At least for today's class, use your partner to check your work. Say, hey, which equations are you choosing? Like maybe you guys are doing 1 and 2. Say, okay, what'd you get for equation A? And just verbally check so you can make sure you both get the right answer. But I'll give you guys the next 5 minutes if you could go ahead and do example 3.
No.
Yes, this is goodness.
You have to read and you have to read math.
You have to read and math. It's like fun worlds together. Rah, rah, rah. Okay, we got the complaining out. Let's try it together. John receives an inheritance of $50,000. His financial advisor suggests that he invest this in 3 mutual funds. How many variables do you think we're going to have? 3, yes. A money market fund, which returns 5% each year. A blue chip fund that returns 9% each year. And the high-tech fund that returns 16%. John wants a total first-year return of $4,000. To avoid excessive high risk, he decides to invest 3 times as much in the money market funds as in the high-tech stock fund. How much should he invest in each fund? Okay, what variables do you guys want to use? A, B, C? X, Y, Z? All right, X, Y, Z. X will represent the money market fund, which returns 5% of value. Y will represent with the blue chip fund, which returns 9%. And Z will use to represent the high tech, which returns 16%. Okay, how much total money is he investing? $50,000. So I know the amount that he invests in the money market, plus the amount that he invests in the blue chip, and the amount he invests in the high tech, has to total $50,000. Now the next part that talks about money, it says that he wants a total first year return of $4,000. So how am I going to use my variables to represent that? Yep. Nice. 0.05x plus 0.09y plus 0.16z will tell you how much money you've returned in each investment, the total value of the money. And he wants the value of that return to equal $4,000. Okay, the next thing that's described, it says to avoid excessive high risk, he decides to invest 3 times as much money in the money market fund as in the high-tech stock fund. This one, I want you to think about setting up this third equation. I want you to confirm it with your partner. So I'm going to give you a minute with your partner to set up that third equation. My partner, what did you say for the third equation?
X equals 3Z.
Yes. X is equal to 3 times Z. The amount of money has to represent 3 times the amount in the high tech. So if the high tech, we put $10 in, we'd have to put 30 in the money market fund. Okay, so here is our system. We've got 3 equations. This one, we wouldn't really want to use those steps that we described. There's something easier. Where would you guys go about? Zach?
Substitute.
Yeah, take 3Z, substitute it in for the value of X in both equations. And then we'll very quickly have a system of equations in 2 variables. So if I call this equation 1, 2, and 3, then equation 1 would look like 3Z plus Y plus Z is equal to 50,000. Combine like terms, and that would give me 4Z plus Y is equal to 50,000. And using equation 2, I have 0.05 times 3Z plus 0.09Y plus 0.16Z is equal to 4,000. 0.15Z plus 0.16Z would be 0.31Z plus 0.09Y. 0.05 times 3, so that would be 0.15. And then I added that to 0.16 is equal to 4,000. Now this would be, for example, my equation A, and this would be my equation B. What would I have to multiply equation A by in order to eliminate Y? Yeah, so if I multiply this by negative 0.09, then that would give me negative 0.09 times 4 for that Z, which is negative 0.36 Z minus 0.09 Y is equal to 50,000 times negative 0.09, which is negative 4,500. No. Negative 4,500. So now when I add these two together, I'll have negative 0.05Z is equal to negative 500. And divide that, and I get that Z is equal to $10,000. So the amount of money I'm investing in the 16% return is $10,000. How much am I going to be putting in the money market fund? Yep. So X, which is the money market, is 3 times 10,000, which would be $30,000 in the 5% return. And then how much would I be putting in the 9% return? Yeah, 10,000, because 10 plus 30, or 10,000 plus 30,000 plus 10,000 has to equal that $50,000 investment. So there would be my 3 answers.